Chapter number 5, Force and Movement. But the topics we are going to cover in this video are related to force. The topics related to movement will be covered in the next video. These slides are designed particularly for the students of O level, IGCSE, GCE, and Edexcel, but the students of metric can also get benefit from it. Let's start the lecture. Force. What is a force? To move our luggage from one place to another, we either push it or pull it. So force is either a push or a pull that one object exerts on another object. Force can produce four different types of motion. One is that the force can slow a moving object. Force can speed up a moving object. I'll give the examples of these in the next slide. Force can stop a moving object, and force can produce a motion. It's a vector quantity. Vector is a the vector has a magnitude as well as a direction. Units are in Newton, which are equal to kilogram meter per second square. Then we have the types of forces. One is contact force, other is non-contact forces. Forces are which are produced by the interaction between the two objects, right? Contact forces which exist between the objects that are in contact. For example, when a ball comes in contact with the bat, it is called a contact force. When a man pulls a rope, there is a contact between the man and the rope, and there is a contact between the man and the weight. Then we have non-contact forces which do not require contact objects to be in contact with each other. Think about the example. I'll give it in a second. Think about it. Example of non-contact forces. Okay, here it is. Non-contact gravitational force of the earth's pull, the man is coming downwards, right? Non-contact attractive forces, non-contact repulsive forces. It can be magnetic forces, it can be the forces between the electrons and protons, forces between the charges. These are the examples of non-contact forces and contact forces. Then we have balanced and unbalanced forces. In the above example, there are two forces of 300 Newton in the opposite direction. So both the forces are balancing each other. If the resultant or the sum of the two forces is 0, we say that the forces are balanced. In the second example, the left force is 400 and the right force is 300, so their sum will not be equal to 0. So these are unbalanced forces. If the resultant of the two forces is not 0, we say that the forces are unbalanced. Newton's law of motion. Isaac Newton was sitting in a garden under an apple tree when an apple falls on him. He thought that there is some force in the earth which is pulling this apple downwards. So the first law of Newton states that, what is the first law of Newton? You can see in the animation both the arm wrestlers are applying a force in opposite direction, but their hands are not moving. The hands are at rest, which means that the forces applied by both the wrestlers are cancelling each other. That is why their hands are at rest. So if the resultant of the two balanced forces is 0, or if the resultant of two forces is 0, body will remain at rest, as in the case of this book. The book is applying its weight downward and the reaction of the table on the book is upward. So Both the forces are cancelling each other, are balancing each other. That is why the book is at rest. So this is Newton's first law, the first portion of Newton's first law, that if the resultant force apply on an object is zero, the object remains at rest. Every object at rest will remain at rest until an unbalanced force acts on it. This is the first portion of Newton's first law. Okay. Second portion of Newton's first law states that a body moving with uniform velocity in a straight line will keep on moving unless a resultant force acts on it. I have given the example of pendulum here. Why? Because there is no force acting on this pendulum. It is not touching the ground, so there is no frictional force from the ground. It is so it is so polished that there is no air resistance, so there is no friction due to air resistance as well. Because there is no force which is going to stop this pendulum, so that is why it will keep on moving for years and years once displaced. So a body at rest, this is the complete law. The body at rest will remain at rest. A body moving with uniform velocity will keep on moving unless a resultant force acts on it. Newton's second law. If an unbalanced, we were in the previous slides we were talking about balanced forces. Now, if an unbalanced force is applied on an object, the object will accelerate in the direction of force. More the force, more the body will accelerate. For example, in this animation, more the force with which he will hit the lever, more the ball will accelerate. Okay. More the mass of the object, more force will be needed to accelerate. As in the case of this, the bulky boy needs more force to be accelerated as compared to the skinny boy. So, more the mass of an object, more force will be needed to accelerate. So, there is a relationship between force, mass, and acceleration, which is F is equal to ma. So, you can see from this relationship that the force is directly proportional to acceleration, which means that more the force, more will be the acceleration. Force is also directly proportional to mass, which means that more the mass of the object, more force will be needed. But there is another interesting relationship. If we keep the force constant, mass and acceleration will be inversely proportional. For example, in this example, if you hit a ball, a golf ball with a golf stick, and you hit a truck with the same force, what do you think? Which of these two objects will accelerate more? Obviously, if the mass is small, acceleration will be more. But if the mass is more, acceleration will be less. Lesser the mass, more is the acceleration, as in the case of a golf ball. More the mass, lesser is the acceleration for the same amount of force, for example, in the case of the truck. Okay, doubling the mass will halve the acceleration because they have inverse relation. Mass and acceleration have inverse relation. So, doubling the mass will halve the acceleration. Newton's third law. For every action, there is an equal and opposite reaction. For example, this old man throws the ball in the forward direction and his cart moves in the backward direction. So, the action is in the forward direction and the movement is in the backward direction. If the ball strikes a wall, it comes back and hits the person. The man applies the force on the wall, and the wall applies the force on the man. What is the conclusion? Conclusion is that every action has an equal and opposite reaction, and the reactions are action and reactions are equal in magnitude and opposite in direction. For example, if a man is applying a force on the wall in red color, and as a result of that force, the wall is also applying a force on the man, which is in the blue color. Then we have friction and its effect. What is friction? Friction is a force that opposes or tends to oppose a motion between the surfaces in contact. If we microscopically see the surfaces, like in the figure, a boy is applying a force on the wooden block towards left, and friction force is opposing the applied force in the opposite direction. You can see it in the figure. The red color force is the action force from the boy. The orange color force is the friction force in the opposite direction. Frictional force is due to the irregularities between the surfaces. A fine polished surface will have lesser friction than a rough surface. When there are irregularities in between the surfaces, they get interlocked with each other. So that is why friction increases. So this is the effect of friction. The first effect of friction is that it produces heat. We saw in the previous slide that the frictional force opposes the motion. Along with that, it produces heat. When we rub our hands to keep them warm in winters, they get hot. Heat produced during cutting of metal due to friction. In friction welding, metals are rubbed together, they melt due to frictional heat and join together, as in the diagram. Okay, friction on the road. There is friction on the road between the road and the wheels of the car, which allow the car to move without skidding. In an emergency, when the driver of the car may have to react and apply the brakes, the car stops. The car's stopping distance is the sum of the following. Thinking distance. Thinking distance is the distance during which the driver is thinking to apply the brakes. Driver is still reacting during the thinking distance. Driver is still reacting. He has not pushed the brake pedals. Braking distance. This is how far the car travels after the brakes have been applied. So the stopping distance is the sum of thinking distance and the braking distance. Negative effect of friction, which should be minimized. How difficult it would be to push this trolley full of load if there will be no wheels. So wheels are used to reduce the contact and hence reducing the negative effect of the friction. Lubricants and grease are used to reduce the negative effect of friction between the moving machine parts. When the gears they mesh with each other, they produce heat, which is a negative effect of friction. So grease or lubricants are used to reduce that. In modern trains, an air cushion is developed between the rail and the wheel with the help of magnetic levitation in order to nullify the friction effect. There are some positive effects of friction as well. The effect of friction can be positive or negative. The positive effects of the friction are there to be enhanced. For example, most of the people and cars skid on the snow due to lack of friction. So the friction should be enhanced between the wheels and the tires. In snowy areas, they use chains around the tires of the cars to increase the friction between the car and the snow. Friction is necessary for walking. Treads on the tires improve the friction between the tires and the roads. Air friction allows the parachutes to slow down. This is also a positive effect of the friction, which allows the parachutists to slow down. Mountain climbers uses chalk powder on their hands to improve the grip. That is also a positive effect of friction. Okay, then we have a circular motion. If we roll a ball in a circle at a steady speed, or if we roll the keys in our hand, in our finger, an inward force will be needed to make the ball follow the circular path. The tension in the string provides the force. Without this force, the ball will travel outward in a straight line. This is exactly what happens if the string breaks. If the string breaks, the red ball will go outward. So there is some inward force which is not allowing it to go outwards. It wants to go outwards, but there is some inward force which is not allowing to go it outwards. That inward force is called the centripetal force. In short, the ball wants to go outwards, but there is an inward force which is not allowing it to go out. This is called the centripetal force. When the bikes go around the curved path on a corner like this, the friction force between the tires and the road acts as centripetal force, restricting it from slipping outwards. Solar system and electron motion. A satellite travels around the Earth in a circular path called orbit. Gravitational pull of the Earth provides the necessary inward force, which is the necessary centripetal force to keep this planet in a circular orbit. When the satellite is put into the orbit, its speed is carefully chosen so that it neither move away into the space nor it comes towards the Earth. Earth and other planets move approximately in a circular path around the Sun. Centripetal force is provided by the Sun. In atoms, negatively charged electrons are in orbit around the positively charged nucleus. Attraction between the opposite charges provide the necessary centripetal force. Okay, next is the topic of deformation. Force can change the shape or the size of an object. For example, we have a spring and we apply a force on the spring will stretch. In elastic deformation, the material returns back to its original position after the load is removed. Force can produce deformation in a body. Deformation can be elastic or plastic. However, if the load is applied, it deforms and then breaks. What is plastic deformation? Plastic deformation is a permanent change in the object's shape, size, which cannot be reversed without applying a force. Right? If we increase the force and exceeds from the elastic limit, the body will go into the plastic region where when the force is removed, the body will not return back to its original position. For example, we have these springs. If we apply a force in the downward direction on this spring, the springs will stretch. For example, if we apply a load of 0 Newton, at that load of 0 Newton, the spring was unstretched and its length was 10 centimeter and the extension was 0 because it was unstretched. If we increase the load to 2 Newton, the extension is 0.4 Newton, 0.4 meter centimeters, right? We again increase the load to 2 Newton, right? There is another 0.4 Newton of extension. Again, we have 0.4 Newton of extension when we increase 2 Newton further. And at the end, we made it 8 with an increase of 2 Newton, and there is another extension of 0.4 Newton. So it means that there is a uniform extension, there is a constant direct relation between load and extension. Okay, the line is straight and passes through the origin. This is the observation of the experiment. The load is double, the extension is doubled, and so on. Extension divided by the load has the constant value of 0.2. If we divide 0.4 with 2, it is 0.2. If we divide 0.8 with 4, it will be 0.2. If we divide 1.2 with 6, it will be 0.2. So extension divided by load always have the same value. These are the observation of this experiment. So we can say that up to point X, load is directly proportional to extension. And that point X is called limit of proportionality. Extension is also called elongation or deformation. Hooke's law. Hooke's law states that load is directly proportional to extension within the proportional limit. The formula is F is directly proportional to X, where F is the force, X is the extension. If we remove this proportionality sign, then there will come a constant K, which is called Spring's constant, right? K is a spring constant. So the ratio of force and extension will remain constant. So that's it. The topics of movement will be covered in the next video.